Let's take a look at this first example. We are on Unit 3, Lesson 2, determining the domain provided with the equation of a function. So I'm looking at the three rules here, and I can see that we do have a radical. It has a positive nth root, and it is in the domain, and for that reason I need this portion to be greater than or equal to 0. X squared minus 1x minus 20 has to be greater than or equal to 0. Jumping back to Unit 2, I'm going to take this right now and I want to find the hash marks. So x squared minus 1x minus 20, I'm going to set it equal to 0. I'm going to factor. What multiplies to equal negative 20 and combines to equal negative 1 would be negative 5 and positive 4. So in factored form, x minus 5 and x plus 4 equals 0. I'm going to set each one of these factors equal to 0 and I'm going to solve. And in doing so, I end up with an answer of positive 5 and an answer of negative 4. Now, those are my hash marks. So I'm going to do my hash marks over here. I have a negative 4 to the left of the positive 5. Then I'm going to come up above and I'm going to look at the inequality symbol. And based on what we learned in Unit 2, it says we're going to include that as part of the solution set, or in this case, the domain. And now I have to decide, is it yes, no, yes, or vice versa, no, yes, no. So it's alternating since I don't have a duplicate answer. So let's choose one answer here. Like, I think the easiest one to plug in is 0, and I come back up to this portion. If I plug in 0, and I can do it here if we prefer, so I have 0 squared minus 1 times 0 minus 20. I want to know, is negative 20 greater than 0? Negative 20 is not greater than or equal to 0. So this part is a no, and this would be yes, and this would be yes. So I believe that the domain is negative infinity up to negative 4. We include it, and 5 all the way to positive infinity. Now we could use a graphing calculator to see, is this correct? Let's check. So when I plug this in, it's a little unique in how we plug it in, but we have a couple different ways to do that. Let's see if I can remember how to do this. I go to math, and I come down here, and I'm going to make that into a 4, and then inside is going to be x squared minus 1x minus 20. I'm going to graph it, and we can see that it goes all the way to negative 4, and then it picks up at positive 5 and goes to the right. Okay, let's look at it. In this next example, we're provided with a function. We're going to identify the domain and illustrate it on a number line, as well as putting it into function notation. So I can see that I do have a radical, and the nth root is even. So I'm going to come up here. It's in the numerator. This is the rule I'm going to apply. So this portion has to be greater than or equal to 0. X squared minus 9x plus 18 has to be greater than or equal to 0. Let's start by just setting it equal to 0 first, and let's factor. What two values multiplied to equal positive 18 and combined to give us a negative 9? That would be negative 6 and negative 3. Now when I set each one of these factors equal to 0 and I solve, I'm able to get hash marks, I'm able to get hash marks of x equals 6 and of x equals positive 3. So I'm going to come on my number line to positive 3 and positive 6. I come back here. I can see that we want to include them. So I put a dot, and now I have to decide, is it yes, no, yes, which means shade, no shade, and shade, or is it vice versa? All right, let's get started. So I'm going to choose the easiest point. I think 0 is the easiest point to plug in as long as it's not a hash mark. So 0 squared is 0, and if we want to use a calculator to speed this up, we can. Some of us would prefer to use mental math, and that's okay as well. So I'm plugging in 0, I'm pressing enter, and I get 18. Is 18 greater than or equal to 0? It is. I plugged in 0, it's true. That means everything to the left is true and everything to the right is true. So negative infinity all the way to 3 and 6 all the way to positive infinity. Now notice these are closed dots. That means we need to include them as being part of the domain. So if we plugged in 3 and anything below that, or 6 and anything above that into this particular function as an input value, we would receive an output value. If we tried anything between 3 and 6, not including the endpoints, we would not get an answer. Let's look at two very simple problems. Now, this problem does not have a denominator, so I don't have to worry about rule 1, and it does not have a radical that has an nth root that's even, so I don't have to worry about rules 2 or rules 3. That means that our domain is all real numbers, negative infinity to positive infinity, and it would look like this in a number line. So if this is 0, we are shading everything to the left and to the right. This is often confusing for students because they see a radical, but when they look, the nth root is odd. When the nth root is odd, we do not apply the second rule. That's only when we have an even nth root. For that same reason, we have all real numbers. So negative infinity to positive infinity. Let's look at another one. Now we have a couple things to consider with this particular function. First, I can see that I have a variable in the denominator, and for that reason, x plus 3 cannot equal 0. So x plus 3 cannot equal 0. That means x cannot equal negative 3. Now let's come up above. I have an nth root that's hidden that's positive, and it's in the numerator, so I'm going to apply the second rule. That means the value inside has to be greater than or equal to 0. X squared minus 5x minus 14 has to be greater than or equal to 0. I'm going to take this portion and I'm going to factor it and set it equal to 0 to find the hash marks. So x squared minus 5x minus 14 is equal to 0. What multiplies to equal negative 14 and combines to give us negative 5? That'd be negative 7 and positive 2. X minus 7 and x plus 2 equals 0. When I set each of the factors equal to 0 and solve, I end up with an answer of x is 7 as a hash mark and x is negative 2 as a hash mark. So I'm going to come over here, and this is where it gets a little more complicated. I'm going to look at some of these numbers here. So we're going to have negative 3, negative 2, negative 1, here's 0, 1, 2, 3, 4, 5. Ooh, I got to go look for the 6 and 7. Okay, so 7 right now, I come up here, not only is it a hash mark, notice that it's going to have a closed dot at 7, and we're going to have also a closed dot at negative 2. Now I have to decide, is it no, yes, no, or vice versa, yes, no, yes. Whenever it's a yes, we shade. Whenever it's a no, whenever it's a no, we don't shade. So I think the easiest number to plug in is 0. I'm going to come back here and plug in 0. 0 squared minus 5 times 0 minus 14. Is negative 14 greater than 0? It's not. I chose a number in between. This is a no, this is a yes, and this is a yes. So my first part says that for working with the numerator, I believe that the first part looks like this. Okay, now the second part. All the second part says is x cannot equal negative 3. So here is an open circle at negative 3. Now we need to combine these two. So how do we combine them? So we're going to include negative 7 to the right, and negative 2 excluding negative 3 all the way to the left. And we can write that as negative infinity to negative 3, don't include it, and negative 3 to negative 2 include, 7 to positive infinity, and this would be our domain.